Welcome to Praveen Patil College of Diploma Engineering and Technology. Myself Raj Gevare, working as lecturer in mechanical department. We are looking at the practicals for the subject industrial engineering and quality control. So in this we are going to check out the last practical, which is of the drawing and interpreting the control chart. So over here we are able to get a control chart in to which we can have we should not have a frequency and decimal. Now in this we will be utilizing this p chart information, number of defects item and the percentage of whole. Now for an example, the number of broken eggs in a carton and the number of leaking tubes in a box. So by this, the C chart are utilized to distinguish the defects where they can be formed from the one defect. Now the program outcomes are the basic knowledge, discipline knowledge, experiments and practice, engineering tools. So over here we are going to check out this number of defects are given. So it is been p chart is been represented. This is the example of from the data. So over here there are 10 samples. So in the 10 samples the number of products, that is of 200, and from the 200 the defected product are indicated. So like 12, 4, 8, 3, 7, 6, 0 defects, 8, 5, 9. So this is what. So from this data we will be seeing the how to generate this p chart. The second type is about the c chart generation. So over here in the c chart generation there is a production of nano cars. So here the total count is of 10, which we are able to see it from here. That is nothing but this total count is represented over here as 10, and this is nothing but the total number of the product. Now from this defected we will check out the defects in the car, that is 11, 3, 13, 4, 2, 5, 3, 3, 4, 5. So these are nothing but the defected car which are being produced. Now based on this we are going to do the analysis and we are going to plot out the charts. So we have to utilize some of the friction defects, that is the formula is nothing but the d by n, which we are going to utilize this formulas. So for the p bar we have to take the average, which is nothing but the sum. So I will just indicate the sum part. So sum of this p by n. So this sum p is nothing but, say, this part I will just show you. This sum p is nothing but the number of defected product in all sample, and n is nothing but the number of sample taken. So based on this, by utilizing this we are going to utilize this in the formula for calculation purpose. So I will just clear out. Now in this part what we are going to check out is the two parts for the p and the c charts. Now see, this is the part of the table which we have seen in the given sample. So this is the p chart tables which is indicated on the left side, and on the right side it is indicated the c chart. So these are the values. So n is sigma n is nothing but the total number of products. Okay, product, this is nothing but the total number of product, which is 200. Okay, and this p bar is for the p chart representation, which is sigma sum of d upon sum of n. Now this sum of d represented for the number of defects, sum of all number of the defects, sum we are saying, or we can say the mean part of number of defect. So this value we are going to check out, and the next part, which is nothing but the n. So n over here, all the calculation part is done over here. I will just show you. So this is what we have taken, the sigma d, which we have obtained it as 62. So we are substituting the value in terms of over here, and the n value, which is nothing but this one. So this is total 10 number of counts, so it becomes 2000 divided by 10 simple, and we are able to obtain it as 200, and sum of total n is nothing but 2000. So this 2000 value is put it over here. I will just clear out, and from that we will be getting in terms of percentage. We can use convert it in percentage, and we will be checking out the VCL term. So this, it's UCL. UCL is nothing but the upper control limit. See here, it's mentioned over here. It is mentioned over here. It is nothing but the upper control limit. And LCL is nothing but the lower control limit. So I will just clear out this part now. So in order to get this part, we have just directly utilized the formula, and we have put it over here. So here this p value which we have already obtained, which is 0.031, which we have substituted over here. So it's have a formula of 3 into under root p1 minus p by n. So p value which is obtained, that is nothing but 0.31, which we have substituted over here, and 1 minus p, once again p value 0.31, divided by n is nothing but this value. So once we get this, we will be getting the final value of upper circuit limit, say this upper control limit UGL value. So in terms of percentage, it is nothing but 6.77. So for lower control limit, okay, we have to only use, instead of plus sign, we will be utilizing minus sign. So see here the difference. I will just clear out, and I will just highlight the difference between the two formulas. See here, upper control limit plus, and in lower control limit minus. Same steps are there, and by substituting the values of this p, we will get the lower control limit. So same way for this example, what we are going to do is we are going to go for this. So first of all, we need to check out what is the total number of defect and number of the sample. Based on this, we will calculate this C value, which is nothing but 1.43. C bar is based on the Poisson. See here, C bar, this one, C bar is nothing but based on the Poisson's ratio, which is a number of defect. It is already mentioned over here. This part I will just show you. See here, P bar is the average fraction defect, and C bar is based on the Poisson distribution, which is nothing but the average defect. So by utilizing this formula, we are going to get the average number of defects. So see here, I will just show you C bar. So C bar, by utilizing that formula which is mentioned, so there it is nothing but it is equivalent to total number of defect divided by number of supplies. So total number of defect is nothing but the number of addition of this, which is 43, divided by 10 is nothing but this value. So we will get the number of defects as this one, and the UCL, upper control limit, of this C bar is nothing but only difference is of plus sign and minus sign. See, C bar plus 3 under root multiplied by under root C bar, and this lower control limit is C minus 3 into under root C bar. So here this we have got 4.3, which we will substitute over here as well as over here. Only difference is upper circuit limit and lower circuit difference limit is of minus sign. So we will utilize this and we will get all the values. So this is how we have obtained, and we have got the results which are based on the difference proposed. So that's all about the experiment. We will stop here. Thank you.